Yes, welcome to another claims video where we have a brief look into certain concept. And today we will be looking at the stochastic interest rate. So throughout our years and our careers, we have learned that interest rate is basically fixed throughout the year, even in the future. But then as as actuaries, we know that interest rate cannot be fixed. It's not necessarily always fixed. The ones that are normally fixed are the lowest interest rate. So interest rate can be probabilistic. So we are going to learn interest rate as a probabilistic variable, right? So, and it will change at any given point, like at any time. So there is an important assumption that you'll have to know is that the interest rate for each year will be independent from each other. So meaning that the interest rate of this year cannot affect the interest rate of the other year, right? So anyway, so in order to understand the characteristics of this stochastic interest rate, we will have to find its mean or its expectation, right? So to find the expectation of the interest rate, we will say that the expectation is going to be J. So it's important to find your average expectation or your mean expectation of the interest. I said the mean expectation. Okay, that's wrong. You will have to find the mean of your interest rate, J, because it will enable you to do a lot of calculations. A lot of calculations actually will come back to J. And another thing that you'll have to know is the variance of your interest rate, which in this case I'm going to call it S squared. So I am going to look at one example where we use the stochastic interest rate. So I am going to look at the accumulated value of the amount 1, right? So again, let's say maybe you invest 1 rand this year, right? You invest 1 rand, so he's gonna gain an interest rate of I1 during the first year, and then gain the interest rate of I2 during the second year, and then at the end of the year of the time, it's gonna gain an interest of IN at the end of year N. So you can write this thing like this, right? So to find the expectation of our accumulated value, this is what we do. So this is your expectation of the accumulated value down here. So you can see that now this thing looks very familiar to the formula of the present value of the accumulated value that we have learned throughout our years. So, but then there's a catch. The catch is that the interest rate is now the expected interest rate. It's not just I, but it's the expectation of the interest rate. So to find the variance, now since this it's okay, so since this thing is a probabilistic thing, you cannot find its variance. So to find the variance, you will need to find the expectation of the accumulated value squared, because variance is going to be equals to the expectation of A squared minus the expectation of A and all squared. So this squared actually square the whole expectation, right? So we need to find in the very least the expectation of A squared, and to find it, this is how we have arrived at, right? So this is the answer we get. So these things fine, we can get them, but then there's another trick that they would that they would ask in your exams. So there's a whole lot of things in between here that you have to learn, but I cannot teach them now because this is a claims video. Anyway, An important thing to consider is that what if your interest rate follows a distribution? In this case, let's say that 1 plus your interest rate follow a log normal distribution. If it does follow a log normal distribution, it simply means that the accumulated value or the product of the interest rate for n years, which is in essence the accumulated value, it will also follow a log normal distribution. Now with parameters mu, again n times mu and n times sigma squared, and the ln of this thing, and the ln of the again and the ln of the accumulated value, or the logarithm of the accumulated value, will follow a normal distribution. Now realize that it has changed from log normal to just normal distribution, and this is important because once we know normal distribution, we can solve it easily because we have the normal distribution table in our books as well as in our exam, so it's so much easier to find this answer. So how do you even find our mu, these mu's and our sigma squared? How do you find them? Now your mu, right, again, so remember that your 1 plus I, so you can find the expectation of 1 plus I, and normally you will be given the expectation of 1 plus I, or you will be given the expectation of I, right? Even if they give you the expectation of I, you can just say that 1 is equals to the expectation of I, right? So anyway, that answer should be equals to this. So you can solve for this, and then you also gonna do this one for variance as well. So variance of 1 plus I is gonna be equals to E, the exponent of 2 mu plus sigma squared, all times the exponent of sigma squared minus 1, right? This thing can be simplified to this. This thing can be simplified to mu plus sigma squared all over 2 times 2 multiplied by the exponent sigma squared minus 1, right? As you can see, this thing looks very familiar. It looks like this. So you can solve it like you can just say your answer is gonna be 1 plus j. So you will have 1 plus j squared E sigma squared minus 1. So this is where I will end in terms of stochastic interest rate. So I think the best thing you can do to understand this subject is to actually practice more. So I will post a video where I work out an example of this soon. So for now, I guess I can say that it's the end, and I hope that you are studying productively. So thank you.